All right, so our last lesson here. We're going to look at the sine and the cosine law word problems. And again, I've said this before, and I'll say it again, that the most troubling questions in any math class, any level, any grade, are word problems. You're taking English, you're making it math, or drawing some kind of a math. All right, so again, I'm going to go through the word problems that are on the lesson that were on the webpage. 3 examples here. Now, again, this is where we start to mix things up, right? So you have to figure out which law am I using, the sine or the cosine law. Now, again, here's a quick way to look at it, is that the cosine law, there's only 2 situations where you have a non-right angle triangle and you either know all the sides, so that's SSS, side, 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 or you have SAS, where you have the side, then the angle, then the side. All right, so that doesn't just mean you have 2 sides and an angle. You have to have the 2 sides and you have to have the angle in between it. All right, so on that note, and then of course, all the other questions, we'll use the sine law. All right, so here we go, example 1. So again, with word problems, again, this is my coping mechanism because I struggled with word problems because I wasn't much of an English person when I was younger. So I always read the question first. On a 520 meter hole, a golfer's tee shot goes 175 meters and is 20 degrees to the right of the direct path to the flag. The second shot, miraculously, I guess, goes directly into the hole. How far did the golfer hit their second shot? All right, so when I'm looking at this question, I'm going to break it down sentence by sentence. All right, so the first sentence says, on a 520 meter hole, a golfer's tee shot goes 175 meters, 20 degrees to the right of the direct path to the hole. All right, so right away, I'm going to be able to draw something. All right, so I'm going to call this G. There's my golfer. And directly to the flag. So I'm going to put a little flag here. And directly to the flag. That's a nice straight line, believe it or not. That's 520 meters. That's what it's telling us. Now, this person hits their first shot out to the right. All right, and how far did they hit it? 175 meters. And it was at a 20-degree angle from the direct path to the hole. All right, so that's where we're at. So I'm going to put this, put a little dot there. And then the next time it says on the second sentence, the second shot goes directly into the hole. And so we go from here and it goes straight in. Must be a good golfer. And we want to know how far did the golfer hit their second shot? Well, if 175 was the first shot, X here will be our second shot. So there's my triangle. I'm reading the question again. I always like to make sure I read it even a third time to make sure I didn't miss anything. So on a 520 meter hole, a golfer's tee shot goes 175 directly 20 degrees to the right, which I've got. The second shot goes directly in. How far they hit their second shot? Perfect. All right. So now I look at my situation here, and I've got to determine a value of X. And the thing is, what do I have here? Out of these 2 situations, am I going to use the cosine law or the sine law? And what you can see is I have a side, angle, side. So this means I'm going to use the cosine law to find the side length. And that formula again is a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. All right. Now, again, we've been rearranging the formula. With a word problem, I don't necessarily need to do that. Because here's what I can do. Is if I want to find X here, which I guess will be side A, I'm going to make down here, directly across from this angle here, is going to be angle A. All right, so I just drew it in a different color. Then I can, I guess, label my other sides here. I'm going to say that this is B, side B, and this is C. Angle C, I should say. And that would make, well, now that I have my A's, B's, and C's, now I can use my formula properly. But again, with my givens, I always write down what angles I have, or information, and the 3 sides. All right, so again, I've labeled my diagram so that I'm finding side A, which I guess you could call X. All right, I have angle A. There's 20 degrees right there. And now my sides, make sure I get in the right spot. Across from angle B, that's 520. And across from angle C, that's my 175. And again, I know to use my cosine law because I have side, angle, side here. All right, well, now it's time to substitute into my formula and solve for a squared, which happens to be x, which we're looking for. So I'm just going to substitute right away. So instead of a squared, I'm going to put x squared. That's what we're looking for. All right, I have b squared, which is 520 squared. I need a calculator for that for sure. I have c squared, which is 175 squared. All right, minus 2bc, so minus 2 times b, which is 520, times c, which is 175, times the cosine of angle A, and angle A, again, is 20 degrees. All right. Now, again, with this formula, you got to follow Bedmas. Well, not just this formula, all of our formulas, we got to follow Bedmas. All right, and so we've got x squared. All right, so we get 520 squared. Let's see here. I'm getting, wow, big number, 270,400. Big numbers here. All right, plus a 175 squared, which I've got is 30,625. Okay. So again, doing Bedmas, so I'm doing my exponents, and then over here, I just still have these numbers multiplied. And again, cosine of 20 degrees. I'm not doing anything special here. I'm just going to change the way it looks by actually figuring out what cosine of 20 degrees is, and I get 0.94. All right. Now, again, this is something I went through. Most common mistake with the cosine law when you're finding a side is following Bedmas right at this step. And so now that I've done exponents, I have to do the multiplying here, multiplying those 4 numbers over there. So I still have my 270,400 here, plus my 30,625. I multiply my 4 numbers, and I get 171,080. 171,080. All right. Now, again, following Bedmas, I do my adding and subtracting here. So I put those numbers together. Let's see what I'm getting here. I got 129,000, big numbers, 945. Okay, and of course, again, things are getting simpler. It's always good in math. I want to get my x value by itself. And so I square root both sides, and I get x to be, let's see here, a bit of a crazy distance. Let me see here. 360.48 meters. So a much longer hit than their first hit. Their first hit was 175 meters. Their second hit is 360 meters, 0.48 meters. So a much bigger hit. Tiger Woods-ish, I guess you could say. All right, so there's a one word problem there. All right, let's try.
I have a quick question.
Yep.
Does it matter where you put like angle A, B, and C? Like, does it matter where you decide to choose?
No, it doesn't. It kind of did in this example, because here's why. I wanted a squared. I didn't want to have to rearrange this formula, so I made sure that x was side A.
Okay.
Then made across from it angle A, being 20 degrees here. B and C didn't matter.
Okay.
In fact, like you said, none of them mattered, but I wanted to make sure I didn't have to rearrange that formula.
All right, thank you.
So that's why I made side X, side A. Because all our formulas come either as A squared equals, where you're solving for side A, or in the case of the angle formula, it's cosine angle A.
Yeah.
So I didn't want to do that extra step. That's why.
Thank you.
Which is a great question, because if you see what's going on there, then that saves you an extra step. If you understand that you don't want to rearrange the formula. So just stay away from an extra step. Extra step, extra chance of messing up. All right, so we get to example 2. All right, so let's see here. Example 2, a lighthouse, okay? All right, so again, I'm going to try to take my information here, read the question, and see if we can draw a nice little picture here. So, example 2, a lighthouse is able to shine its light so that 2 boats, A and B, are visible, or just visible. Boat A and B are 7 kilometers apart, and the lighthouse is 5.7 kilometers from boat A and 6 kilometers from boat B. Okay? What is the angle of spread coming from the lighthouse? All right, so see how I just read the question, get an idea what's going on here. We got 2 boats and a lighthouse. All right, so I'm going to put my lighthouse down here. There's my lighthouse. There's going to be a boat A and a boat B. And of course, we're going to have ourselves a triangle here. All right, so that's what I got just from reading the question the first time. Now I'm going to go through it sentence by sentence and see what we can do. All right, so a lighthouse is able to shine its light so the 2 boats, A and B, are just visible. Okay, got it. So I don't have to do anything. First sentence. Second sentence, boat A and B are 7 kilometers apart. Okay, so I'm going to put that in here, 7 kilometers right here. All right, and the lighthouse is 5.7 kilometers from boat A. Okay, so I'm going to put a 5.7 here. What else we got? Oh, and the lighthouse is also 6 kilometers from boat B. All right, 6K here. All right, now, last sentence. What is the angle of spread coming from the lighthouse? There we go. So there is my diagram. All right. Now, I've got it all diagrammed out. All right. Surprise, surprise. Here we have side, side, side. So once again, I'm going to use the cosine law because I know all 3 sides. Right? Any other situation. Now, coming back to, I'm not sure who asked that question just a second ago. Does it matter how I label things? No, it doesn't. So watch this. Great question. Great lead in. Now I've got boat A and B here, right? And I got a lighthouse. I want this angle. So I am going to call, and again, I'm going to use a different color here. I'm going to call the lighthouse here. That is going to be my point A because I'm trying to find that angle. And so that now I'm not going to have to rearrange my formula, which is cosine of angle A is equal to B squared plus C squared minus A squared divided by 2BC. Which then means, because I labeled the lighthouse angle A, I got to change these. So it is still boat A, but I'm going to call it the C spot. And B, I might as well keep it the same, right? So B is point B. So the red letters are indicating what I'm going to use for my formula. All right, even though I did have a boat A and boat B, well, I guess boat B I got to leave as point C, or point B, but boat A I put as point C. Again, because I don't want to rearrange this formula. All right, now I get down to my givens. My given information here. Again, you got 3 angles in a triangle, and you got 3 sides. All right, so this is again from my red letters. Angle A, that's again what I'm looking for here, which is called X. Doesn't matter. I'm just going to put a question mark there. I'm trying to find angle A there. All right. Now the sides from my red letters. Across from angle A, that's side A. That's a 7. Across from angle B here, that's my 5.7. And across from angle C here, my red C is side C, which is 6. And there we go. So I've got everything sorted out. That's such the hard problem when we're dealing with word problems. Taking the words and coming up with something we've dealt before. Always the hardest part. So now that I have done the hardest part, well, I'm going to do what we've done before. So it's a good little review. I'm going to substitute in my information and solve for my angle here. So let's see here. I got everything with my givens sorted out, so I'm not going to mess anything up here. So B squared is going to be 5.7 squared. plus c squared, which is 6, so that's going to be a 6 squared, minus a, which is 7, so I'm going to have a 7 squared. All right, and in my denominator, I'm going to have 2 times b. Let's be here, 5.7 times c, which again is 6. There we go. So I've substituted in. Again, just following Bedmas. All right, so I'm going to do my exponents up there at the top. Simplify. All right, so 5.7 squared. I have no idea what that is. Let's see here. Pipe that in. It's going to be over 25. So 32.49. Rounded to 2 decimal places. 6 squared I know is 36, and 7 squared I know is 49. All right, and of course I can simplify the bottom, because actually a fraction, the top's a bracket and the bottom's a bracket. So let's see here, 2 times 5.7 times 6, I get 68.4. All right, again, it's getting simpler. Good thing, going the right way. I've got to figure out my numerator there, because I know my denominator here is going to be 68.4. So I figure at the top there, and I get 19.49. All right, and then I'm going to convert that fraction into a decimal. All right, so I get my ratio, and so I take 19.49 divided by 68.4, and I get 0.28. All right, and we just did this earlier this morning, and we did in our last unit. I have the cos ratio. I want the angle. I do cos inverse, assuming again you have your calculator in degree mode. And the spread of this light is going to be 73.44 degrees. Is the spread of the light coming from the the lighthouse. There we go. But again, there's an example where we had side, side, side. So again, that leads us to cosine. All right, let's try another example here. Some big words, a lot of wording going on in this next one. All right. All right, so example 3. Here we go. Let's see here what we got. Again, reading the question first. When laying an underground cable, a workman uses the 250-meter long straight property line as a reference, typically. The angle from one end of the property line to the house is 64 degrees. And the angle from the other end of the property line to the house is 71 degrees. Okay. What is the shortest possible cable length that can be used to get from the house to anywhere on the property line? Interesting. All right. So again, I read the question. Now I'm going to kind of draw a diagram, see what I got. So the first sentence, when laying an underground cable, a workman uses the 250-meter long straight property line as a reference. So I'm going to do that. Here's my property line. There we go. So I'm going to put 250 meters there. That's our property line. All right. Now, the angle, we got a house here. So let's put our house right here. There we go. H for house. All right. So now, second sentence. The angle from one end of the property line, so I guess let's say this one, to the house is 64 degrees. All right. So one end of the property to the house, there's a 64-degree angle in there. And from the other end of the property line, it's 71-degree angle to the house from the property line. There we go. All right, so there's some information. Now, last sentence. What is the shortest possible cable length that can be used to get from the house to anywhere on the property line? Okay, so here's a little bit of a tough question here. What is the shortest possible distance to anywhere? How do you get to the shortest possible distance when you're traveling somewhere? Anybody? It's a common phrase. Shortest distance between 2 points. Whoa. Straight line. Yes. Thanks, Damien. The shortest distance between 2 points is a straight line. And so what we're looking here is we want to, again, this is what companies do. They want to save money. And so I'm going to draw. There's my cable, nice straight line, which means we have a right angled triangle there. All right, now, here's the thing is, I want to solve for this value, which I'm going to call, let's call it x. Now, if I go to solve for x, this comes down to our last unit, where I have a right angled triangle. I have actually 2 of them. But I don't have enough information because I have an angle, but I don't have this side or I don't have this side. I know this whole thing is 250, but I don't know this side and I don't know this side. I go to my other triangle up here at the top, same thing. I have an angle. I want this side, well, it's x over here, but I don't know this side and I don't know this side. So I'm not going to be able to find x right away, but here's what I can do. I can find one of these sides. I can either find this side or this side. So which one did I do in my lesson here? Oh, I mixed up my variables here, but I could say find y here. That side right here, because if I find it then, that will help it find x. So I'm going to have to go 2 steps here. So I've got one big triangle here, but yet I've got 2 little triangles inside. So what I'm going to do is I'm going to find side y here as part of a big triangle, and then use that to find x, which is inside this right angle triangle inside my big triangle. All right, so here, what do I have now in terms of information? I want side y. I've got 71 degrees, I got 64 degrees, and I got this 250. Now, in terms of are we going to use the sine law or the cosine law, I have side, angle, don't have that side. I've got side, angle, and I don't have that side either. So I'm not going to use cosine law. And I don't even have all 3 sides, so they're definitely not using cosine. So I'm going to have to use the sine law. So again, here's what I'm going to do. I'm going to label my house here. I'm going to say this is side A, or point A there. H, I'm going to say is my B for the triangle, and I'll label this as C. Oh, what did I do? I did not do that on my diagram. All right, doesn't matter on my note. So I'm just going to do it fresh. Again, I don't look at my answers here. All right, so now I got angle A. Actually, maybe I better, just to keep it for those of you following around the note. So I labeled, doing the same idea. I put this one as A here in my note, and I did this one as B, and this one as C. There we go. All right, keep it the same as my note on, in case for those of you following online. But again, I'm going to write down my givens. Triangle, you get 3 sides, 3 angles. All right, so I've got 71 degrees is my angle B here. My angle A is 64 degrees. I want side Y here, which is across from angle A. So that's going to be side A is Y that I'm looking for. And what else? We got this 250, which is across from angle C. So that is side C. All right, now we look at, again, using the sine law. Here's the trick, right? Is that first off, you're going to have to use 2 parts. So for me, one part I have to use for sure, it includes the value I'm looking for. Well, I want this Y value. So I have to use the A part, which means sine angle A all over side A is equal to, and then I got to figure out, am I going to use the B or the C part? But to use a second part, you have to know both the side and the angle. I look at angle, or the B part, I'm missing side B. I look at the C part, I'm missing angle C. So how am I going to get around that problem? I already know I'm not going to be using the cosine law, but I'm missing stuff. I'm missing information here. I need to know either side B or angle C so I can use the sine law. Anybody know?
I think I might know. You have to add the 2 angles and then subtract 180 to those added angles
That's
because like all angles should equal to 180, right?
That's exactly it. Yeah. So I can find this angle C in here, just as you said. All the angles inside that big triangle have to add up to 180. So let's see here. I take 180, I subtract 64, I subtract 71, and that'll give me my angle C, which I'm getting to be 45 degrees. There we go. So now I have everything for the C part. I have both the angle and the side. So that's the second part I'm going to use. All right. Set up. Again, the hard part's done. Now it's just the math. All right, so now we're going to substitute in. So I got side angle A, which is 64 degrees, over side A, which is Y. That's what I need. Sine angle C is 45 degrees, sine 45 degrees. And side C is, 250. All right. All right, so again, sine 64 and sine 45, I can just pop those into my calculator, figure them out. So sine 64, I'm getting 0.9, so divided by y. And sine 45, I'm getting 0.71. And of course, the denominator is 250. All right, now we got a fraction equaling a fraction. We've had that happen. Simplifying, I'm going to cross multiply. All right, so I got my 0.71 times y. And then I got 0.9 times 250. All right, so now I can keep going here. Well, 0.71 times 0.9 times 250 is 225. All right, and of course, to get y by itself, I divide both sides by 0.71. And I get my y value to be, let's see here, 316.9. So that's right here, 316.9. So I'm not done yet. Now, this is a double step here. So now I finally got this side. Here's what I want, my x value, right? Well, I have this right angle triangle where, because it's a right angle triangle, I don't have to use the sine or the cosine law. I can go back to my trig ratios. All right, so using my trig ratios, either sine, cos, or tan, we'll figure it out here. I'm going to change colors. So we'll go with green. So again, there's my angle. I'm looking at my small triangle here. There's my angle of 71 degrees. All right. Across from the right angle is my 316. So that means that is my hypotenuse. All right. And we want side x, which is across from the 71 degree angle. And so that would be my opposite. Oops, my opposite is x, not 71, that's my angle. There we go. All right, so now again, a little review of right angle triangle trig ratios. Which trig ratio am I going to use that involves the hypotenuse and the opposite? That's going to be sine on highway. All right, so I have sine of 71 degrees is equal to sine on highway, so the opposite divided by the hypotenuse. All right, and so I got sine 71 degrees, which I can figure out. Let's see here, type that in. 0.95 equals that x over 316.9. All right, and again, what I like to do here, it's the easiest thing, create a fraction equaling a fraction. And so that I can just cross multiply like I did with the sine law here. So I have 1 times x, which is x, good. Is equal to 0.95 times 316.9. Woo! Just in time, getting enough room here. I type that in, and so the smallest cable, which is going to go straight from the house to the property line, is going to be 301.06 meters. There we go. So again, a little bit of a trick that we had before with the sine law, where we knew we had to use the sine law, but we're missing some information. But again, using that fact that all the angles inside of a triangle add up to 180. So that is some crazy word problems that involve the sine law and the cosine law.